Hey guys, welcome back. We have made it to the end of topic 7. This is our last lesson in topic 7, and it's all about proportions in triangles. So more proportions all day long, lots of proportions, okay? Two objectives. The first one is you're going to be able to use the side splitter theorem and the triangle midsegment theorem to find length of sides and segments of triangles. And then you're going to use the triangle angle bisector theorem to find length of sides and segments of triangles. So no new vocabulary today, but there are those 3 theorems that I just said that we do have to go over. So let's jump down to the last page in our packet of the theorems and postulates, and let's review those 3 theorems. All right, so here we are on the theorems page, and we're going to look at these 3 theorems for today. The first one is the side splitter theorem. So if a line is parallel to the base of a triangle, right, so MN here is parallel to AC, then the sides that it creates are proportional. So what this means is that BM to BA is proportional to BN over BC. Okay, so this length is proportional to the full length, and then the same proportion BN would be to the full length BC. Okay, and again, you can reverse those proportions. You can say BM over BN equals BA over BC. You can say BA over BM is equal to BC over BN, right? There's all different ways that you can make up those proportions. The next one is the triangle midsegment theorem. So remember that a midsegment means that you cut the side of a triangle in half on one side and then the side of a triangle in half on the other side, and you connect it, okay? And what happens is that side ends up being parallel to the base, and it ends up being half the length. So if I take GH, right, this length, GH, and I multiply it by 2, it gets me side DF. So it is half the length, right? GH times 2 gets me DF. And then the last one is the triangle angle bisector theorem. So if I have a triangle and one of those angles are bisected, remember that means cut in half. So if one of these angles is cut in half, a proportion gets set up where UX, so the little short length, over UV is proportional to WX over WV. And again, remember, you can set up that proportion in other ways. You can say UX over WX equals UV over WV, right? There's multiple different ways you can set up the proportion, but this is the generic makeup. So the 2 sides that are created by splitting them through the angle bisector are proportional to the 2 original sides of the triangle. So we're going to use these 3 theorems today to create lots of different proportions and solve problems. So let's go back to 7.5 and finish it up. Okay, so let's start here with example 1. It says in triangle JLN, so this big triangle, if L to N, wow, where am I? Okay, so this whole thing is 9.6. What are LM and MN? So we'll call that one Y, I guess. Okay, are the sides divided proportionally? Explain. Okay, so that using our side splitter theorem, right, the proportion is that I can say that, well, I need to know this whole length, right? This whole length is 8. Okay, so I can say the full length, 8, over the first half of the length, which is 3, is equal to the full length on the other side, over just the first length, which is x. So I'm just setting up a proportion here using the side splitter theorem. So I'm going to cross multiply. I get 8x equals 28.8 divided by 8, divide by 8, and I get x is equal to 3.6. So the length of LM is 3.6 units. Okay, so I can get rid of this x here and label it 3.6. So the length MN, which is y, right? So if I add up LM, which is 3.6, plus MN, which is y, I should get the whole length, which is 9.6. So I subtract 3.6, subtract 3.6, and I get y is equal to 6. So that tells me that the length MN is equal to 6 units. So the sides are divided proportionally because of the side splitter theorem, right? If I do, for example, let me erase the y. Let's put in 6, right? If I divide these, 3.6 divided by 3, 6 divided by 5, I will get the same value. So they are proportional. Okay, so the sides, the sides are divided proportionally. Okay. So let's look at the next one. So that's using the side splitter theorem. Here I have BD bisects AC and CE. Okay, so this is the triangle midsegment theorem, and the question is AE parallel to BD? And we say yes, right? AE is parallel to BD by the triangle midsegment theorem. Okay, so by the triangle midsegment theorem, these two lines are in fact parallel, because if I have a side that bisects both sides, it is automatically parallel. Okay, so that's just kind of like going through just general. Now let's actually look at problems and like solve them. Okay, so here I have a triangle. It says, what is the value of x in triangle PQR? So in this big old triangle, what is the value of x? Okay, so let's look. My x's are here and here, TR. So let's just set up a proportion. I can say that PS over SQ is equal to RT over VQ. Sorry, I don't know why I got lost there. Right, so this short end over the long end is proportional to the short end over the long end. So now I just need to fill in my values. Could I have done, PU over UQ and RV over VQ? Yes, I could have, and that would be okay too. Okay, but PS is x plus 2 over S to Q. This whole length right here is 16, right? This is 4, this is 12, so the whole length is 16. And then RT is x over the whole length. 9 and 3 is 12. We're going to cross multiply. So I have 12 times x plus 2 equals 16 times x. So 12x plus 24 equals 16x. I'm going to subtract 12x, subtract 12x. I'm running out of space, so I'll continue over here. 24 equals 4x. Divide by 4, divide by 4, and I get 6 equals x. So there that one is. What is the value of x? It is 6. Okay? So that means that this length right here, 6 plus 2 is 8. So this length is 12. And that means that this right here is 6. So this length is 9. That just looks like a scribble. 6. And that will probably be helpful on these triads here. So then the two triads for you is what is the value of y? Explain. The next one is what is the value of z? Explain. Okay, so hopefully if you haven't paused it and gone over and done them, do that now. If you have, then let's go ahead and go over this. Okay, so the first one is what is the value of y? Well, since I have a triangle, and I'm just going to draw this real quick sketch here of this. Oh gosh, that was awful, wasn't it? And here's y, right? This is 12 and this is 12. This is 9 and this is 9. So that automatically means these guys are parallel. And that means that whatever this is, this guy is twice that. So let's go ahead and fill in this bottom one too. This is 30. So that means that because of the triangle mid-segment theorem, this guy is half of 30, which is 15. So the value of y is 15 units. And that is by, because UV is the mid-segment of triangle PQR. And so by definition, the mid-segment is always half of the base of the triangle. So that's how I was able to get y. Okay. Then the next one is what is the value of z? Okay, so by the side splitter theorem, I can just set up a proportion. So I'm going to fill in, I know that this is 15. Great. Okay, so what I'm going to do here, let's draw the triangle again. Right, I know that this full length is 24. This full length is 18. This is 30, and this is z. Right? So I can set up a proportion. And you know, and there's multiple ways that I can do it. Sorry, I just totally like spaced for a second. Okay, there's multiple ways I can do it. I can do let's draw this other triangle where this is z. Okay, then this side would be 12 and this side would be 16. So I just drew Q, T, S, and here I have Q, R, P. Okay, so I'm just going to set up a proportion, right? So I can use 24 and 16. I can use 18 and 12. It doesn't matter. So I'm going to use 18 and 12. So 18 in the big triangle over 12 in the small triangle. is proportionate to 30 in the big triangle over z in the small triangle. And I'm just going to cross multiply. So I get 18z is equal to, and then 30 times 12 is 360. I'm going to divide both sides by 18. And I get z equals 36 divided by 18 is 2, so 20. By the side splitter theorem, right? That these sides are proportionate. So if I have two of these triangles, the sides are going to be proportionate. Whoosh. Okay, so again, it's very helpful if you draw separate triangles, right? If you draw these triangles as separate triangles, it's a lot easier to see which triangle or which sides correspond to what and things like that. So let's look at another one, a real world. Oh, sorry, you guys have a try it. Woohoo! So AD here is 12. CE is 18. And BE is 24. And it wants you to find the length of BD. So go ahead, set up a proportion, solve, and then when you're ready to go over it, hit play and let's review it. Okay, so as I've been saying right over and over and over, there's always more than one way to write the proportion. In this case, I'm going to go short side, which is 24, over short side, BD, right? BE over BD, which is X, equals, and then I don't even have to find the full side length. I can just do the 18 over 12. I could also have found the whole length of the sides and done that too, but I don't necessarily need to. So we're going to cross multiply. So 18x equals 24 times 12 is 288. Divide by 18. Divide by 18. I'm going to get x is equal to 16. So the length of BD is 16 units. So hopefully the more that you practice it, the more it makes sense, and you're going to get plenty of practice as we continue on here. Our next problem is example 3, finding a length. Okay, and it says a reflecting pool is separated by walkways parallel to Lincoln and Jefferson. So I know that these walkways are parallel to these guys. Sorry. Okay. The city wants to add additional tiling around the pool. How much tiling does X feet represent? Oh, and here's X right here. Lots of different ways that we can set up the proportion. In this case, Y and 24 are not going to help me because I don't know what Y is, right? So I'm going to set up a proportion with these 4 numbers. And literally, we can just do it this way. X over 24 equals 60 over 72. Or you can do like X over 60 equals 24 over 72. Or, you know, lots of different ways. But let's just do X over 24 equals 60 over 72. Cross multiply and solve. 72 times X is 72X. 24 times 60 is 1440. Divide by 72. Divide by 72. And I get that X is equal to 20 feet. So how much tile does X represent? 20 feet of tile. Okay. You guys have a try it, and the try it just says, what does Y represent? So you're going to use kind of the same idea. So let me clear this. And I can fit it. Woohoo. So how much tiling does Y represent? So go ahead, pause the video, and then hit play when you're ready to go over it. Okay, so again, you can set it up exactly as it looks here, and that's totally fine, right? You can do 60 over 72 equals 24 over Y. There's other ways you could have done 60 over 24, 72 over Y. You could have done 24 over 60, Y over 72, right? Lots of different ways we could have done it. Oh, I put 6. I don't know why I put 6. It's funny. It's not the answer. It's Y. and we cross multiply. So 60y equals 28, or 24 times 72 is 1728. Divide by 60, divide by 60, and I get y represents 28.8 feet of tile. So hopefully not too terrible here. Just again, I mean, the whole lesson is just setting up proportions and solving them. We're going to skip example 4 and we're going to go straight to example 5, which is using our last theorem that we haven't used yet, the triangle angle bisector theorem. So remember, this one says that when you have an angle bisector, which here I do, DB is an angle bisector because it cuts angle B in half, that what sides are created are proportional to the original sides of the triangle. So like X is proportional to 10, and then CD is proportional to 16. So let's look here. What are the values of AD and DC? Okay, so if this whole length is 13 and this guy is X, then CD has to be 13 minus whatever X is. So this guy right here is 13 minus X. Okay, so the whole length is 13. You take off the X, and that's what you have left. So it'd be 13 minus the X gives you that last little piece. And so the proportion here that you use on an angle bisector theorem is you take one of the sides that's been split, which is, let's say, X, and that is proportional to the original triangle side, which is 10. And that is equal to the other half, or not half, but the other side that's been left, which is, in this case, is 13 minus X, over the original side, which in this case is 16. Okay, so that's the proportion that we're looking at. And then we just do the same thing, we cross multiply, right? So X times 16 is 16X equals 10 times 13 minus X. Looks like a B, let me fix it, sorry. 13 minus X. So I have 16X equals 10 times 13 is 130 minus 10X. Let's add 10X to the other side. So I have 26X equals 130 divided by 26, divided by 26, and I get X is equal to 5. Okay, so X is equal to 5. That means that the length of AD is 5 units. And the length of DC is 13 minus 5. Well, 13 minus 5 is 8. So 8 units. So it's just another example of setting up a proportion. Okay, so for your try it, it's the exact same thing. Part A is what is the value of X. Part B is what are the values of GH and GK. So go ahead and set up your proportion, cross multiply, solve, and then plug it back in to find those values. When you're ready to go over it, hit play. Okay, so here we have an angle bisector, right? It cuts angle H in half perfectly, which means that 3x minus 7 over 3x plus 3. So this side, so GK over GH is equal to 12 over 18, which is KJ and HJ. And I'm just going to cross multiply. So I have 18 times 3x minus 7 equals 12 times 3x plus 3. Let's see here. 18 times 3 is 54, so 54x minus 7 times 18 is 126. And 12 times 3x is 36x. 12 times 3 is 33. Wow, 36. Whoosh. Okay, I'm going to subtract my 36x to both sides, which leaves me 18x minus 126 equals 36. I'm going to add my 126. So 18x is equal to 162 divided by 18, divided by 18. X is equal to 9. So there's part A. X is equal to 9. I just set up the proportion and solve. Then it says, what is the value of GH? So GH is equal to 3x plus 3, which is 3 times 9 plus 3, which is 27 plus 3. So GH is equal to 30 units. So there's the first part. The other one it wants me to find is GK. GK is 3x minus 7. So 3 times 9 minus 7. So 27 minus 7. So GK is equal to 20 units. And there you have it. Okay, so I know that the angle bisector, the triangle angle bisector theorem is a little bit more complicated, but it's still just a proportion. You're still setting it up just as a proportion like we've been doing in 7.4 and 7.5. So that is it for 7.5. You know, I'm going to say it a million times, but make sure that you reach out if you have any questions, if you need any help, either on the notes or on the practice or anything. Make sure that you reach out and get the help that you need, and we will see you soon.